Okay, hi YouTubers, and welcome to this, my first attempt to make a getting started learning STM32 video. Um, Let me start by saying that this is indeed the first time I've done this, and I have no experience. I'll learn as I go along, and I guess if I end up making a lot of videos, they'll get more and more streamlined as I go around. The second thing I want to say right off the bat is I have deliberately chosen not to script these, so they are not well scripted. I figure it out as I go along, and I do that deliberately. My reasoning being that no matter what you know about embedded development and embedded programmers, you are constantly in a situation where you need to figure out something new or something you haven't tried before. And an important part of the process is to know how to find the information. So I want to show that. I want to show, okay, I stop here and I need to figure this out, and I'll show part of how I figure that out. I should probably also mention that I will not actually record my person in these videos. My primary reason is I live in the tropics, and I don't use aircon in my office, so I rarely wear a t-shirt, and I'm not going to bother you with that. You don't want to see that, believe me. So here we go. I should also mention my motivation for doing these videos. There is a lot of advice out on the internet, on YouTube, on Google, and a lot of that advice is, I find, poor advice. One advice that typically come up when people ask how do I get started with STM32 is, oh, you just install Arduino. I seriously dislike that response because Arduino is an it's okay for hobbyists that just want to run their aquarium pump or what do I know, but as an actual development tool for embedded programming, it is not very strong. It lacks some features that are pretty essential. For example, the ability to debug your code in a meaningful manner. So I would not recommend the use of the Arduino development tools IDE for anything really, except a quick hobby project. I need to get this running, and I don't really want to understand what I'm doing. I don't care about that. I just need something running. So I am going to propose a different approach, and I'm going to start this from scratch. Okay, so let's start with STM32. What is STM32? STM32 is overwhelming when you start to look at it because there's literally, I don't know the exact number, but there's probably several hundred different variants of STM32, and it's important to understand the difference between them and what essentially makes them the same to a large degree. So let's start by a simple Google search here and look for STM32 family. Now we immediately get a link up to a Wikipedia article we can look at, and we get ST's own site introducing the STM32 microcontrollers. And here we get a list of the different types of STM32s you have. Let's ignore the wireless for now. Let's ignore the ultra low power ones, and let's look at mainstream and high power. So you basically, everything is called STM32. That describes the core and the architecture, the overall architecture of the device. Then you have different families. You have the F 0, you have F1, F3, F4, you have G0, which is a relatively new series, F7. And a typical starting point, if you just want to learn how to use STM32, is actually the STM32F1 family. I would normally recommend a slightly more powerful one, and I typically will use the F4 family, which is have more memory, have more features than the F1. But if you want to learn STM32, it really doesn't matter which one you're using. You can use the G0, you can use L4, L0. I guess it doesn't matter. But it's important to understand the difference between the families. Now, the STM32 article lists all the families. There are more than they showed over there and describe the detail. I'm not going to go through this here, but I am going to show you my own website, which is the STM32 World. Now, I didn't make this website to actually get a lot of traffic. This website is my personal scratch pad where I write my own documentation so I can find it again whenever I need it in a quick manner. It is reasonably well organized once you browse around a bit, and it contains a lot of information. So let's start by looking at the page over here called STM32. Now, an important part is to understand the part numbers, and they are really confusing when you look at them first. They will all start with STM32, and then they will have the family. The family could be F, we already mentioned those. It could be L for low power, and apparently they also have an A. I never seen those, I never used those, but I have used F and I have used L, and also the W actually, but we can get to that at a later point. Now the next three numbers is the actual features in that particular processor, and one of the most common ones is STM32F103, which is the basic run-of-the-mill cheap but relatively feature-rich processor. Unfortunately, it's also the most cloned processor there is, so I would recommend to avoid it, because if you end up with a clone, they might work well, but there will be bugs in it, and you will end up spending an enormous amount of time trying to sort out these bugs rather than actually being productive. I typically will go for the 405 or 407, which is a relatively high performance family or processor in the STM32 family. The next, after the 3-digit number, there is a letter, and that letter will indicate the pin count on the particular MCU. So typically you will have F103 will typically come in a 48 pin, so it will be a STM32 F103 C something, because it's a 48 pin. The F405 typically come in a 64 pin, so that will be R something. The next number indicates the size of the built-in flash in the microcontroller. Typically, F103 will probably be an 8 with 64 kilobyte, or it will be a B with 128 kilobyte. We'll get back to that. The processor I will typically use is STM32F405RG. So the G indicate that there is a megabyte of flash memory built into this. The next two numbers are not really interesting for development, but these STM32 MCUs come in different modules, different package types, and typical package size is quite flat pack, but it doesn't matter unless you actually want to create your own PCB and your own device. And the last one is the temperature range, where most of the cheap ones is 6, which is up to 85 degrees. But there are industrial processors, MCUs, that can go to much higher temperature than that and still survive. Next up, if you want to do this, you will need a development board. And here is a good place to come up with a warning. If we go to AliExpress, for example, and search for STM32, you will get hundreds and hundreds of matches. And a very, very common one that you see a lot are these, which are known as blue pill boards, because they are almost always blue, and they always come with an STM32 F103, either the CB or C6, so different memory sizes. They're cheap as chips. It's like less than $1 here. But the problem with them is that they're quite often fake chips. They're not from ST. They are a clone out of China somewhere. And you will end up with things that doesn't work and things that doesn't work as expected and waste an enormous amount of time. If you want to go cheap and you want to go for AliExpress, I would recommend these, which are often known as black pill boards. There are there are two variants that are common. Let's see if we have it here. Let's see what we have. Yes, we have. There is the F401 and there is an F411. As you can see, the price difference is roughly $1. I'm sure you can find them cheaper than that. And I would recommend you go with the 411. It's a fairly powerful little board, and to the best of my knowledge, these are not. They're always original, at least the MCU on them. The boards are made from different vendors, and some of them are probably have other issues, but as a starting point, it's a good starting point to get started with some development. You also need a programmer, a JTAG tool, or as STM call them, an stlink. Stlink is a device that you plug into your USB, and you can use that to flash your target board. You can also use it to single-step debug and all kinds of other features. Some of them actually, not these cheap ones, but some of them actually comes with extra features where you can do serial console monitoring in the same device. We'll get back to that later. Now, as you can see, you can get this for about $1.30. I think you can get them for $1 on AliExpress. So you can get started with $1.39 here, and one of these boards at free. So $4, so roughly $5 for a development board and a programmer. Then you have everything needed to get started with this development on STM32. Now, for a beginner, I would not recommend these Chinese knockoffs. ST themselves make a series of development boards called Nucleo. And if you look at their website, you can see the STM32 Nucleo boards, and they come in pretty much every single STM32 processor, and you can just basically pick whatever you need. Now, the beauty of the Nucleo boards is that they come with a built-in programmer. So the ST-Link device is actually built into these boards. So you don't have to worry about that. You don't have to worry about cables. You don't have to worry about any of this. Let's find a good one. Here was one actually with STM32F103, so let's have a look at that. Okay, that doesn't work very well. I don't know this website very there. Download data brief then. There. You see that the top of the board is actually the stlink device, and at the bottom of the boards you even have an Arduino header, but you also have the straight out, it's not standardized, but you have all the pins, IO pins are pulled out to a header out here, and so this would be a very, very good starting point. They are slightly more. I think you can get them down to about $15 for one of these boards, and it's a very, very good starting point for development. Now, in this video and this video series, I will actually be using my own development boards, but it's important to understand that it doesn't matter which one you're using, as long as you are aware of which one you're using. So I will be using, let's see, close that. I have made my own STM, I call them STM32World boards, and basically I have my own programmer here, which is essentially ST-Link. ST-Link is not open source firmware, but this one is close enough to the original ST-Link device that it can run ST's firmware. It can be flashed into it, and this one is basically just stacked up with oops, sorry. So what I'll do is I'll stack it up with an MCU board, and you end up with a stack of, do I actually have a photo of that? I do here. So the idea is you can just stack them together, and here is an example of how that looks. So probably this particular stack, there's probably an ST-Link device down here and the MCU, and then that looks like a flash chip of sorts. So you don't have to worry about cables and all. But if you're using an STM32F black pill board, which I probably have a photo of here, different black pill boards, and again, it really doesn't matter which one you're using. The important part is that you know which one you're using. Now, no matter what development board you're using, and I know that programmers are not really necessarily interested in electronics, but you need to be able to learn how to look at the schematics. So whatever development board you have, make sure that you have a copy of the schematics. And here we have an example of the black pill boards, and this will show all the things that are on that board. For example, there is a key on that board. How is that key wired up? It's wired up to a pin called PA0, and if the button is pressed, it goes to ground. That's what you can see from the schematics. You can see the reset button, it's actually pulled up to 3.3 volt, but if you press the button, it is pulled down to ground. So you need to have access to a schematic to be able to see the finer details of how whatever board you are using is actually wired up. Of course, my own boards, the schematic is here. I'm not actually selling these boards at the moment. I mean, I could be talked into making them, but I don't think I can make them at a competitive price, and that's why I haven't done it. It's merely something I do for my own amusement, if you like. Now, once you have a development board, whatever development board that is, whether it's a black pill or it's a Nucleo, the next step is to learn where to find the documentation. And this is probably the most important part of everything. Now, I have on my website here, I have linked pretty much the one I use. I have STM32 official documentation. This is the documentation provided by ST. And you can see here I have for the F1, the 103, if you want to go with that, for the 405, the 411, which is the one that is being used on the black pill boards. And you need the datasheet. It cannot be repeated. You need to get the datasheet and you need to learn what is in the datasheet. I don't think anybody, unless you actually want to design a PCB, you don't have to read all of it, but you have to know what is there and where you can find it. So if we're looking briefly at the 411 series STM32 F411, that's the MCU that is being used on the black pill boards. You can see that it comes in different packages with different pin numbers. You can get it with 64 pins, 48 pins, 100 pins, 49 pins, and of course the features depend on how many pins. You can see the different clock speeds. You can, let's go down here. After the index, there's typically an overview of the family and what features are there. Where is that? Description here. So you can see table 2, you have these. You have two 411XC and 411XE, and they differ in terms of flash memory. They have identical RAM, identical timers, but the GPIOs of course differ depending on exactly what family we're talking about. They all run up to 100 megahertz. Some of them have different channels of analog to digital converters, ADCs, and so you need to understand which processor is on the board and then read this document. One thing that differs widely on, let's see here, the block diagram. It's important to understand how these MCUs are wired up internally. So they all consist, all STM32s, this is what is the same about them, consist of an ARM core. That can be an M0, it can be an M3, it can be an M4 core. The difference in the core is basically the instruction sets are slightly different, but if you are developing in C, you mostly don't care about that. You also have the JTAG, the debug interface, which is tightly coupled to the core. You have the interrupt vector table, so you can basically configure what can interrupt. You have DMA, and typically in an STM32 you will have two data buses and clock buses inside, and then you have a number of peripherals, and they are connected to different buses. So you can see, for example, here the UR2 serial port is connected to APB1. See that down here. Whereas, what do we have over here? You have some SPI interface here that is connected to the APB2. UART1 is connected to APB2. UART2 is connected to APB1. This is important because these two will typically run at different speeds. Typically APB2 will run faster than APB1, but we'll get back to how that is actually configured when we start actually developing for this. But the block diagram is very, very important part of the data sheet, and you need to understand the exact MCU that you're using. Then it'll go through all the peripherals and what does it have. And another thing that is important is the pin out, which comes quite a bit down in the data sheet. Before that we came across the timers. So each STM32 MCU will have a number of timers, and they have slightly different functionality. Roughly they are divided into the general purpose timers. We can count up or down, or that's what a timer does. And advanced control timers, and what make them advanced is they can do other things. They can for example, count pulses and stuff like that. And you can see that there's also typically a couple of 32-bit counter resolution timers, whereas most of the timers only have 16-bit. And some timers are on the APB1 bus and some timers are on the APB2, which basically change the frequency they can run at. How fast can they count? It's important. I wouldn't say if you're starting with STM32, you don't really have to read this, but you have to understand where to find it. That is absolutely essential. You can see you have 3 UARTs in this particular MCU, and they can go up to a certain frequency, and you can see here that the UART1 can actually go up to 6.25 megabit per second, whereas the UART2, because it's on the APB1 bus, can only go up to 3.12 megahertz. So it differs slightly. Same for all the other peripherals in this processor. What I want to show you is down here, comes so roughly a quarter down in the datasheet. You have the different packages and the pinouts. How are the different pins named and where are they located on the physical chip? Now, typically on an STM32, you have a number of ports, and each port will have up to 16 bits or GPIOs, general purpose input output. So all the PA, you will have one 16-bit value that defines all the pins, and whether they're being used as input or output, they can do both. So you can see on this, you will have on the F411, you will have port A, port B, mostly up here, port C. So there are 3 input-output ports with up to 16 channel bits in each port. Some of them with more pins, you will have port E as well, port D. E is F, probably not, I can't see it. So that's it. Next up, you will have a list of the pin definitions, and here it's important to understand the package that you're actually using. On the black pill board, it is this one. So you can see this PE is not available on that particular package, but had it been available, this is what it would have done. So down here we have the port that are actually available. So you will have, for example, PA0. Remember that was the one the button was wired up to. You can see that's pin 10, and it can do different things. It can run as a timer channel, it can run as CTS in UART2, or it can send an event out on a reset, or on an interrupt or whatever. It can also be an input channel for analog, so it can read an analog value that will go into ADC1 channel 0. So it have all pins on an STM32 will have a primary function that is the function after reset, and it can have alternative functions which you need to enable in the program. After all these, that goes through all the pins, there's a table that actually show you an overview. So you can see PA0 and the alternative function of this. Let's find one can do a lot of things. You have PB3 here. You see, it's actually used as JTAG debugging. It's used for debugging. It can also be wired up to a timer channel. It can do SPI clock. It can do UART, RX, TX. It can be I2C, I2C. I generally call it I2C, just to be clear about that. Most people will call it I2C, but that's just a semantics. So that's basically the datasheet. Browse through the datasheet even if you don't read it, but browse through it, know what is there and where to find it. Uh, Memory map is also very important. You'll get back to that, and it will show you how the power is wired up to the chip. And I mean, from a development point of view, that's not very interesting, but it is interesting to understand where to find this documentation. So that's basically an overview of the STM32 family and overview of the datasheet. There is a lot of other documentation available. They also have the reference manual, and the reference manual of these STM32 processors is absolutely terrifying. This one is 844 pages and it documents everything. Now again, I would suggest that you open this, you know where to find it, and you browse through at least the table of contents to know what is in here. But the reference manual is that. It is where you go and look if you need some information about a little detail that you were wondering about. So that is pretty much the introduction to the STM32 family. What you need to get for a development board, we might dive into some of these topics later, and as a starting point, where to find the documentation. All the documentation, you can see I list some of them here. These are typical. As I said, my website is my notepad, and this is what I have been using myself at some point. But if there's another family, Google is your friend, and you can simply Google, say I want STM32F303 datasheet. I'm sure I didn't link that. And you'll find it on ST's website, and here is the STM32F303 datasheet. Important to know where to find the information. Okay, now when you have the hardware, you need the hardware. You need a development board, you need a programmer. They can be built together in the Nucleo board. ST also have something called Discovery board. Let's see, STM32 Discovery, which is just another family of development kit. They typically have a bit more features than the Nucleo board, but well, it doesn't matter which one you're using, as long as you have one and you know where to find the documentation. It really doesn't matter. The next thing you need is a development kit. And I should mention here that I am running Linux. I'm only using Linux, and in my opinion, it's by far the best development platform out there. But if you run Windows or you run Mac, these tools are available for those platforms as well. Now, what I would recommend for a beginner, and I cannot state this strongly enough, is a tool developed by ST called STM32 Cube IDE. So if I search for STM32 Cube IDE, you'll see that the first link that come up is actually ST's own page describing this. It's an integrated development environment. It's a debugger. It can do a lot of stuff, and I would recommend that. I cannot strongly enough recommend that. As a professional tool, if you ever become a professional developer, it has some flaws and some reasons why you might not want to use it for that. But as a starting point, it is by far the easiest way to get started. So simply go to ST's website, go to the development tools and click Get Software. I should mention, so you can see it's available for Windows, it's available for Red Hat, it's available for Mac. It's available for Debian, and even though I use Debian and I run Debian, I actually prefer the generic Linux version. So I will usually say this one, you get the latest version. It'll ask you to confirm the license agreement. I accept that. It will ask you to log in. You have to register. You need to register anyway. So I already have a login, so I log in. And now it should pop up. The websites sometimes run a little bit weird. I don't know why it takes a while sometimes, but it usually works eventually. So it should pop up now and start the download in a few seconds. It's coming now. Oh, yeah, well, there we go. And now it'll pop up. There we go. And I put it in downloads. So it's basically a zip file that is quite big. I think it's roughly, my internet's very slow. By the way, you should know that. I think it's roughly one, but you can see I actually have downloaded it before, but I'll download it again. It's roughly a gigabyte, and that's it. I'm probably going to cut a little bit of this. 100 megabytes. It's almost done. Let's go back to my website. A bit more about my website I can do while that is still downloading. I have over here a section with documentation. There's the official documentation. There's some details about some of that. There's an overview of the families, which is a pretty cool overview. Then I have a section with hardware. I have a section with the black pill. I also have a section with the green pill boards, which is the cheapest ones. So there is actually a schematic. Oh, sorry, no, I messed up. I meant blue pill. So never mind. Green pill is my own attempt to do like the blue pill, but with an STM32F103. You can see also there's a section with the stlink. These stlink devices are the official ones from ST Microelectronic, and I absolutely hate them. I do not understand why they made these. There are two things I hate about them. First of all, they're using a mini USB. I haven't used mini USB connectors for years, and it's just so annoying to have to find a special cable just for this. Second of all, they have no labels on the pin. I don't know what possessed them when they decide that. Put the bloody labels there. Every time I have one of these, and every time I use it, I have to Google the pinout because I don't remember it. Even the cheapest ST-Link out of China, which are these ones, they are clones. They have nothing to do with ST, but they have a pinout labeled on the box, and they work just fine. So yeah, I don't like the original ST-Link. Now, I should mention that I actually made my own, and they are listed, it's listed here. So I made my own programmer, which have a pinout that I appreciate, which, the schematics should come up. There we go. So I have a lot more pins out on the header than the standard programmer. Open image in your tab there. There we go. You see I have the, okay, I should talk about these debug pins. Essentially to debug STM32 you need two signals. You have the clock signal and a DIO. So these two pins are the ones that are wired up. You also have an optional pin called SVO. The SVO pin is not available on the cheap Chinese clones, but it is available on ST's official ones. You can optionally have a reset pin, and I also have serial data out on this one, so my device can run as a serial dongle, or it can run as a programmer. It can do all of it. It can also supply power. So if I wire this up to a target, I just wire the 3.3 volt straight to the target device, and it will have enough to power that device without a problem. This was my development. You can see the device. Where do we have a good picture? Here is a bunch of them that I made. You simply have a header at the end. The pins are labeled on the back side of the PCB. Why didn't I show that in a picture? Up, close that. I actually closed the window. Okay, here. There must be a picture of the backside somewhere. There. Well, basically on the back side, the pins are labeled. So I have 5 volt, 3.3 volt out. I have power ground. I have the debug pins, the clock and DIO. I have the serial point pins, and I have a couple of extra pins. Can actually reset the target device. SVO is serial wire debugging, and it can be used to monitor variables, stuff. We'll get back to all that at a later time once we have the software installed. So I'm done downloading. Now, as I said, it's a zip file, so it needs to be unpacked. I will typically just do that on a command line. There we go. So it is STM32 CubeIDE 116. I unzip that. Inside it will have one file, which is a shell script that does all the installation and contains all the so in order to install STM32 CubeIDE, you simply run that shell script. Bash. You have to run it with bash because it's not executable. So there, bash, and run that shell script, and it'll come up verifying the archive integrity, uncompressing the installer. Of course, there's terms and conditions that you have to accept. We accept that. We need to install the tools to actually talk to the stlink device, and I typically just install it in my home directory in a folder there. So let's do that. It will install STM32 CubeIDE. It takes a little while. Okay, there's another license agreement. I don't know. I thought I accepted that already. There's one more. And then it asked me if I want to install Sega J-Link. J-Link is an alternative to ST-Link by a third-party company. I don't have one, so I don't really install that. So that's it. We have now installed STM32 CubeIDE. Now, STM32 CubeIDE is, as the name indicates, an integrated development environment, but it also contains all the tools necessary to flash and debug. So it really is a very complete package, and it is, as you can see, quite easy to install. Now, in order to run it, I simply call the binary directly, which is, you can see I have different versions installed here. That's why I usually keep the old 16 was the latest one. And then there, that is the executable, and I fire that up and it will come up with STM32 CubeIDE. First, it'll ask me to select the directory, which is a workspace. A workspace can contain different projects in the same workspace. I really don't care where you put it. I will usually have separate than here, but for now let's just run with the standard. It will then fire up and show me the release notes. I am not interested in that, so let's look at that. It tells me that it's currently associated with another version. That's okay. There is a uses statistics agreement, whatever, not interested. And then STM32 Cube ID is running. So this is basically the IDE where you have everything. Let's try one thing here. Let's see if we can actually see my ST-Link device. I'm not going to. And you can see I actually can see the ST-Link. I can update that to the latest version. I guarantee you I don't have that. So I upgrade my ST-Link to a new version. So basically, I have STM32 Cube ID installed. I can communicate with my ST-Link device. Now, I will make one little recommendation before I end this video, and that is STM32 Cube ID is complete. It basically contains everything you want. But there is another link device I like to have, and that is if you search on our GitHub, I usually GitHub ST-Link. There is a suite of open source tools available called ST-Link. Command line tools. They have a command called stinfo, stflash that can be used to manipulate these things from the command line. I'll strongly recommend that you download the latest version of this and install it. And just to show you what they actually do, you have a command called stinfo, which can be used to probe what is available. And you can see I have one ST-Link programmer. This is the version. This is the serial number. There is a device connected to that which have 1 megabyte of flash and 196 kilo of SRAM, and the chip ID is this, and it's an STM32F4 something 5. It is a 405 in reality, so that is it. It can also, there is a command called stflash, which can be used to flash firmware to the device. I'll strongly recommend you download that tool. So that's pretty much what I had tentatively intended for this first video. An overview of the STM32 family, an overview of where to find the documentation, what documentation you absolutely need, what development hardware you need to get started with this, and at least one tool. There are other options you can use. Microsoft, what is it called? There's other options, but STM32 Cube ID is by far the most complete. So I'll leave it at that. As the first video. Please feel free to give me comments below. Bear in mind, be nice to me. This is the first time I'm doing this, and English is, by the way, not my native language, so you probably complain about that too. And I'm not very experienced, and I did this unscripted. I'm sure later videos will have much higher quality, but hopefully you learned something. Now feel free to ask questions in the comments. I will read them, or suggestions on where I wasn't clear enough or something I need to go into more details. Feel free. I should also mention we have a Facebook page, facebook.com, which is called STM32World. There, a Facebook group actually. Feel free to ask questions there. Feel free to comment. There are some really clever people around, so you will usually get a good a good response. So STM32 World group on Facebook, and or my website STM32 World. I also do have Twitter, but no, don't worry. Facebook or the website or comments below this video here on YouTube. That's about it. I stop now. Next video will start with the first application in STM, probably flash a LED and do some debugging on that. Stay tuned.